NIOSH Lifting Equation, an equation to evaluate lifting and lowering tasks. What is the NIOSH Lifting Equation? The NIOSH Lifting Equation is a tool used when analyzing manual lifting and lowering jobs and for determining the relative risk associated with overexertion and low back injuries. It integrates the use of biomechanics, psychophysics, and work physiology, or energy expenditure, to determine the relative risk. The NIOSH lifting equation was initially created in 1981 by the National Institute for Occupational Safety and Health, or NIOSH. The equation was later revised in 1991. The purpose of the tool is to identify dangerous lifting jobs that could potentially pose risk to the low back and lead to low back pain or even injuries. The results of the equation provide users with a recommended weight limit called an RWL and a lifting index, or LI, for the design of manual material handling tasks when lifting and lowering loads. When should you use the NIOSH lifting equation? The tool should be used to determine whether a lifting or lowering task can be performed without increased risk of developing lifting-related low back pain. For two-handed lifting activities, such as lifting a box off of a pallet, note that one-handed activities cannot be evaluated using this tool. The results apply to 75% of the female and 99% of the male populations. What are the variables that go into the NIOSH lifting equation? Horizontal hand distance, vertical hand height, distance between the vertical heights of the origin and the destination, asymmetry or twisting turning angle, hand coupling, frequency of the lifting task. The load constant for the NIOSH equation is 51 pounds or 23 kilograms. This is the maximum weight for lifting an object under ideal conditions. The NIOSH calculation is measured at both the origin or start and destination or end of the movement, and the maximum lifting index is used as the final score. Let's go through each of these parameters in detail. Horizontal hand distance. This value is the outward reach distance from the midpoint of the hands to the midpoint between the ankles. Horizontal hand distance is measured at both the start or origin and the end or destination of the lift. This parameter is the most critical. Vision calculates this measurement and inputs it into the tool. Vertical hand height. This value is the distance from the floor to the midpoint between the hand grasps using the ankles as an anchor point. Vertical hand height is measured at both the start and end of the lift. Vision calculates this measurement and inputs it into the tool. The vertical location value is used to compute the next variable. Vertical distance traveled is calculated by subtracting the vertical location between the origin and the destination of the movement and taking the absolute value. Vision calculates this measurement and inputs it into the tool. This same value is used in both the origin and destination calculations. Asymmetry angle. This value is the angle between the asymmetry line and the sagittal plane. The asymmetry line is the line that connects a point between the ankles and a point on the floor directly below the middle of the hands. The sagittal line is the line passing through the middle of the body. Vision calculates this measurement and inputs it into the tool. Hand coupling. This value describes the quality of the grasp between hand and container and vertical locations of the object. The user inputs this value into the tool, selecting from good, fair, and poor per the following definitions. Good means a comfortable grip. The hand easily wraps around the object. Fair, the handhold is less than optimal. You have to grab the corners or underneath of a box. Poor, requires a pinch grip. Bulky or hard to handle objects, non-rigid or handleless bags as an example. This can be subjective but has the least influence on the final recommended weight limit and lifting index. If in doubt, use the more stressful classification. Frequency of lift. This value measures the number of lifts that occur per minute, per hour, or per 8-hour workday. The user enters this value into the tool. Weight of the object. This value is the actual weight of the object the subject is lifting. The user inputs this value into the tool. This information is used to calculate the lifting index, resulting in whether the job is safe to perform for 75% of the female population and 99% of the male population. The formula is that the lifting index equals the actual weight of the object divided by the recommended weight limit. Let's review the task parameter limits for the NIOSH lifting equation. Horizontal hand distance must range from 9.8 inches to 24.8 inches. Vertical hand height must range from 0 inches to 68.9 inches. Vertical travel distance must range from 9.8 inches to 68.9 inches. Asymmetry angle must range from 0 degrees to 135 degrees. Frequency must range from 0.2 to 15 lifts per minute. The vision system will allow inputs outside of these ranges. Results may not be as reliable. NIOSH lifting equation results. Recommended weight limit. The recommended weight limit, or RWL, is the weight of the load that nearly all healthy workers could perform over a substantial period of time without an increased risk of developing lifting-related low back pain. This number applies for 99% of the male population and 75% of the female. RWL is computed for both origin and destination, and the lower recommended weight limit is selected as the worst case scenario for the entire task. NIOSH lifting equation results, lifting index. The lifting index, or LI, is a term that provides a relative estimate of the level of physical stress associated with a particular manual lifting task. The lifting index is the relative estimate of the physical stress associated with a manual lifting job. Lifting index equals the actual load weight divided by recommended load weight, and LI of less than or equal to 1.5, the job is considered safe. If the LI is greater than 1.5, the job is considered unsafe. As the magnitude of the LI increases, the level of risk increases, and greater percentages of the workforce are likely to develop lifting-related low back pain. Please note that NIOSH states that although some workers can safely perform tasks with a lifting index of greater than 1.5, nearly all workers are exposed to a higher risk with a lifting index of greater than 3.0.